Okay, let's look at an ionic reaction or equation, as it's sometimes called. So say we have excuse me, silver nitrate plus sodium chloride, and we put these in water. So we look at the solubility rules and we see that sodium chloride is soluble, so sodium chloride will dissolve in water and it will break up into sodium plus ions and chlorine minus ions. And so we write sodium plus, and we use a parentheses AQ, which stands for aqueous, meaning it's dissolved in water, plus chlorine minus, which is dissolved in water, so we use the parentheses AQ. And we also have silver nitrate. And we look in the solubility table and see that silver nitrate is also soluble. And so when looking at a compound like this, we try to match the molecular ions. So we see the NO3 group, and so we would look in our molecular ions table list and we would see that NO3 is a molecular ion, NO3 minus. So we would know that silver breaks up into the +1 charge, and the nitrate molecular ion is -1, and so these are all dissolved in water. So now, will they react? Well, so I'll draw an arrow here for the products. To determine if there's a reaction or not, we look at all the possible pairings. Well, could it pair with sodium? Well, they're both positively charged. Like charges repel, and so they would not pair. Silver, could it pair with chlorine? Well, yes, we look in the table and we see that silver chloride is insoluble. And so when silver and chlorine bump into each other in solution, since they're insoluble, they will stick together and form the solid. So we will have silver chloride solid formed. Now sodium and the nitrate ion won't stick together because sodium nitrate is soluble. So we will still have sodium ions, aqueous, plus nitrate ions floating around in water. So this is called the Ionic Equation. Complete Ionic Equation because it lists all the ions, even the same ions on the left and right side of the equation. You can see that sodium plus is both on the left and right, as is nitrate ions. This would be a precipitation reaction because silver chloride would precipitate out of solution as a solid. We can write a net ionic equation, and here we look at what's on the left and right side of the equation, and we let the arrow for the chemical reaction be an equal sign like in algebra, and if something's on both the left and right side, we can cancel them. So we can cancel sodium. Let's write it over here quickly. So sodium is on both sides of the equation, so we can cancel sodium. Nitrate is on both sides of the equation, so we can cancel nitrate. And so what's left is silver plus and chlorine minus, giving silver chloride solid. So this is called the net ionic equation because it only has the species that are changing or involved in a reaction. The other species, sodium and nitrate, are called spectator ions because they are not involved in the reaction. They're just floating around in solution watching what's happening.